Akibu Systems was founded in March 2008. Akibu delivered innovative products, solutions, and services to those who need very high-performance computing and data transmission for HPC and data center markets. We have strong hardware and software team members, develop the products using PCI Express as interconnects of HPC, PCI Express fabric networks. In these years, Akibu have designed and implemented hardware switch and software of open-floor switch. Today, we are going to introduce RG5800 SDN switch. This product fully supports open-floor 1.3 specification and supports hardware pipeline processing of multiple floor tables up to 8 tables. We are using FPGA to implement data plan. It enables low latency processing. This picture shows block diagram of RG5800. RG5800 has two boards, which are processor board and accelerator board. Those boards are connected through PCI Express Generation 2. Processor board mainly handles communication with control plane, and the acceleration board handles packet processing such as matching, modification, and forwarding. Our processor board is using quad-core PowerPC. Working speed is up to 1.5 GHz and embedded with 4 GB DDR3 SDRAM. Xilinx FPGA Vertex 7 is used for hardware acceleration. It supports two 10 Gb Ethernet and 48 1 Gb Ethernet physical port, and two 1 Gb Ethernet as management port, which communicates with control plane. These ports connect to processor directly. FPGA can access external memory, 20 megabits TCAM, and 272 megabits QDR2 plus SRAM. TCAM enables wildcard search of much fields. SRAM stores actions and statistics counters. RG5800 has 380 watt 1x1 redundant power supply unit. 32-bit Linux runs on the processor. Open vSwitch plays an important role in switch software. Generally speaking, OVS uses physical NIC as data path. However, we modified OVS to utilize FPGA as data path to accelerate processing. As this picture shows, OVS controls data path through the device driver for FPGA. The switch supports open-floor 1.3 specification. You can define maximum 16 floor tables and configure pipeline processing of multiple floor tables up to 8 tables. Also, RG5800 supports 4096 meters and supports meter band types, which are drop and DSCP remark. You can use group action. It supports group types, which are indirect and all. In the future, we will support OpenFloat 1.4. RG5800 SDN switch fully supports OpenFloat 1.3 specification and supports hardware pipeline processing of multiple float tables, up to 8 tables. Today, we are going to demonstrate an example application by using multiple tables. This picture illustrates demo environment. It is composed of RG5800 SDN switch, a laptop PC as OpenFlow controller, and 3 desktop PC. We installed new SDN framework in laptop PC. Flow entries are delivered when switch connect to the controller. Desktop PCs are connected to the switch, and they communicate each other through the switch. In demonstration, PC1 transmits packets to PC3 through PC2. Before packets arrive to PC3, various actions are executed. For example, it push pub VLAN tag, translate network address, field specific protocols, and limit bandwidth. Next picture illustrates actual data flow. PC1 is iPerf client. It sends UDP packets to port 1 of the switch around 600 megabits per second. Incoming packets are pushed VLAN tag, then forwarded to port 3. Outcoming packets from port 3 go through PC2, then arrive to port 5. PC2 is there to bridge, to dump intermediate packet header. It doesn't modify incoming packets. Incoming packets are pubbed VLAN tag, modified source IP address, access controlled, limited bandwidth to 200 megabits per second, and then forwarded to port 7. Outcoming packets from port 7 are received by PC3. We defined 5 flow tables for each function layer. Table 0 is for ingress port. Table 1 is for VLAN. Table 2 is for network address translation. Table 3 is for ACL, and it forwards specific protocol or port number. Table 4 is for QoS. In this case, it refers meter table. Actual flow table and the meter table entries are like this. Now, let's look at actual demo movie. Demo environment has already been set up as we explained earlier. We use iPerf to measure bandwidth, which is broadly used by network engineers. If we want to measure more accurately, we should use packet generator appliance. First, please look at PC1 screen. In upper window, around 600 megabit per second UDP data is sent to switch port 1 by iPerf client. In lower window, outgoing packets from PC1 are dumped. We can observe at 02.1Q, VLAN tags are added to the original packets from PC1. VLAN ID is 100. In upper window, we can observe about 200 megabit per second UDP data are received from switch port 7. We can observe VLAN tag stripped and the network address modified.